there are a number of different satellites that's purpose is to observe objects around their area. Now, most of these are Earth-facing objects, although there are a number from other planets. And there are a couple of different ways that they manage to do this. There are a large number of varieties. In general, they use the same kinds of bands that are used for the observatories, the orbiting observatories or space-based observatories. But there are a couple of other little interesting tidbits that can be used. So this is an example of one of the satellites. This is the GOES satellite, or one of them. It is a weather satellite that is operated by the United States, NOAA, I want to say. And it's used to detect the cloud patterns throughout the whole world on a regular basis. There are a number of these. They're extremely useful, and they're used for other things. This antenna that you can see here is used to assist with navigation, among other things. But the main thing that they're known for is most of the global images that we receive of the entire Earth to use to identify weather patterns. So these have really changed our lives. Now, there's, of course, a number of different types of them. There are two different types, generally speaking, of instruments. You have active instruments where they transmit either a radar pulse or a laser beam down to the surface, and they receive the signal that comes back from there, and they use that to try to detect something interesting. And then you have passive instruments. These are your typical cameras. They may be using infrared or visible or other bands that can be used to detect whatever characteristics they're wanting to learn about a particular area. So on the left, you have the Mars Reconnaissance Orbiter. You have the Highrise Telescope, which of course is a famous remote sensing instrument around Mars. I partially wanted to show this. This has been called a spy satellite around Mars. Now, they don't actually release pictures of spy satellites. There are a number of them. They're used, but this is a fairly good idea of what one might look like. You'll have one or two large telescopes, probably larger than this, to be honest. You have another few instruments that are used to detect some particular purpose. They might be a little bit more flexible in their pointing than the Mars Reconnaissance Orbiter is, but this will give you an idea of what one might look like. On the right, you have the Mola Instrument. The Mola Instrument was a part of the Mars Global Surveyor, and what its job was is it sent a laser beam straight down to determine what the distance was of the ground below, and it's through this instrument that we were able to have a global elevation map of Mars. And it's one of the early complete maps of the entire planet that we have of Mars. Now, part of it depends on how there's limitations to the size of the telescope and the resolution that you can get. Now, the three things play against each other. There's the frequency, which usually you want to receive a certain frequency. So there might not be a lot of flexibility there. There's the size of the telescope, and there is the resolution size that you can get. And in general, these lines go down. You're probably not going to have a spacecraft that's bigger than maybe about this line right here. You can see James Webb Telescope, 6.5 meters. That's a huge, huge telescope. So you're going to be limited in your resolution that you can get from that. You could have a deployable antenna where you release some wires and make it larger once it gets on orbit. And so maybe you could have 10 to 15 meters to do some kind of radio wave observation. But for the most part, these instruments are in the infrared to visible ultraviolet range. It can be used for a number of things. On the right, we have just a simple example of what a picture might look like. There are two generally speaking, types of imaging sensors these are not radar type instruments like SAR, but there are what's called push broom cameras, and there are framing cameras. Now, framing camera, your cell phone is an excellent example of framing camera. Pretty much any camera you own, well, with one exception that we'll talk about, will be a framing camera. If you have, it takes the entire picture more or less at the same time and is able to be used there. Now, there is one other type of camera that is commonly used in a few places, and that's called the push broom camera. These are used a lot more in space than they are on the ground, but they are used on the ground for anytime you have a document scanner. You just feed the document in and it scans it one bit by bit. Pretty much all scanners use some kind of a push broom camera. What they'll do is they'll read one row of this at a time, then they'll move the paper, they'll read the next row, and so on until they've read the entire image. Now, the spacecraft, they don't move the paper, the spacecraft themselves move. So as the ground moves underneath them, they are able to get a much larger image. So on the next page, we have a couple of examples of two different instruments. On the left, you have an image that came from Cassini. You notice that all images that come from Cassini will be the same size. They're usually roughly square, but it's not always easy to exactly know. On the right, we have an image that came from the Highrise camera, which is a push broom camera. Now, the width of the image is fixed, but you can make this length virtually any length that you want. You're only limited by how long can the camera actually take an image and how long can you maintain the stability of the spacecraft to do that, and we'll talk more about that later. And how much data are you wanting to actually transmit back? So these push broom cameras are incredibly useful for spacecraft because the Earth is always moving beneath them. Now, obviously for geostationary satellites, they can't use this, but they're quite useful in many other manners. There are a number of little different tricks, like they may have a mirror that's moving around to help scan things, or pointing the satellite in different directions, or a large number of different little minutiae that are involved. But this is the basics of what it takes to have a imaging sensor and the types of things that you will need to think about when designing a sensor. Most basic sensors will be framing cameras because they're just a lot easier for the most part. Although you have to take into account that the Earth is going to move beneath you, and so if you're going to do that, you have to take an image very, very quickly to make it happen. Anyways, let me know whatever questions, comments, concerns you guys might have about spacecraft, about these remote sensing instruments in general, or whatever else that you might have. Let me thank you for all your support, and for now, keep on tracking, and we will see you next time. Take care.